Hi there, welcome back to Triplicate, and we haven't done anything on the old Heresy Radical Synthesizer for some while, so I thought we'd drag it out and try and move on with it. Now, the last time we spent probably 2 or 3 videos looking at coupled oscillator algorithms for making a better sound than a simple sine wave, and we pretty much got to somewhere where we can hopefully build something that sounds okay. And before that we were working on the turntable. So originally we tried this piece of plastic on this bearing, which is designed for you to put your cake on top on a board and you can take it around and decorate it, which worked okay, but it's a big heavy piece of aluminium, so you span the turntable and it didn't stop, it kept going. So to overcome that we tried this, which is pieces of acrylic perspex. So there's 2 discs there glued together and they just sit in this ring and they turn, but unfortunately they turn pretty stiffly because there's a lot of surface causing friction. So what to do next? Well, alright, let's try the Mark III. I'll probably reuse this bigger perspex disc because that's no good. I'll show you with the black one, but the black one on the metal bearing did actually work, so I might retain that. So that is a flange, so that screws to the disc. This is a piece of Delrin hard plastic, so that will go through a hole in the middle of there, like that, and that is a collar just to stop it lifting out. And right on the bottom of that goes our little magnet, and our sensor board will actually drop down and go right flat on the board down there, hopefully. And this will go on there, and that will sit on top of it, so the final board will be about that, which I'm not really happy with it sitting up like that, but it's a prototype, right? We're just going to get something that works and then try and get something that works and looks nice as well eventually. This lot doesn't look particularly sleek and modern either. Okay, so I will firstly get this apart, which is glued together with double-sided tape, and that's a good magnet. Figure out a way of centering this and drilling accurate holes for those screws, and indeed get some screws that'll work. Okay, and here we are. How long did I spend making this? Not very long, to be honest. See if I can get it apart again. So, clean this up ish. Clean enough. It's a prototype, and I have printed out and I've printed out on adhesive back paper a template which will stick on there, and it has holes you can see, so then just drill through these and hopefully The flange should mount nicely in the middle. So I need to stick this on here now. Right, so what I hope to do is peel the backing off this, and I can see the ink, the printer ink, through the paper, so I can drop this on precisely from the back. Right. Oh no, no, get off! Get off! Okay, on. That's pretty, that's good enough for a prototype. So, I just need now to cut all this excess off, which is no, that's all bad. Right, so I need to drill 4 3mm holes in there, and we can mount our flange. Exciting! Okay, drilled 4 holes, got 1 screw in holding the flange on, and got a nut on just to hold it in place. So now we need to see, I think the other 3 holes are lined up passably. So let us anyway now try and put 3 more screws in. Come on. Yep, that one's gone through. Just using these dome heads for now because I've got them. Guess eventually it might have countersunk screws in for the look of the thing, but it's fine, it's fine. You use your finger on the outside, not in the middle, because you can't do anything in the middle anyway. So there we go. It's a prototype. That one is not quite lined up. Okay, I've got the drill with 3.5mm, just egg it out 0.5mm and try and bodging in progress. There we go. Oh, there we go. That's done it. So we're going to get 4 nuts on here. Right, got that on there and taken the paper off as well, and the glue was a bit of a swag to get off, and this plastic's getting a bit scuffed up and scratched, but it doesn't matter, it's a prototype. How many times have I said this video? Not enough. So the next thing we need to do is we need to get the old spindle on there. Well, that's easy enough, and through there. So I need a hole 5mm in the middle of this, and then somewhere out here for screw holes to mount it. So don't think. Let's grab a marker. Are we still in shot? There we go. None of these, the location of none of these is critical. Because the spindle will go through the middle hole, wherever it is, doesn't have to be in the middle, and then the 4 screw holes will mark with the thing in situ. 2 centimetres in from the corners. Yeah, go on. Right, I shall go and drill those. Okay, here we are. So I have drilled 5mm holes and 4, I think 3mm holes for the mounting screws. So this end of the shaft is slightly burred over. And there we are. Spins very nicely, too freely in fact, because if you spin it, it goes on. This Delrin stuff is actually used for bearings, bushings, so it is actually a very good bearing surface. So I have tried placing between this and the flange here an O-ring, well a rubber seal, and that didn't seem to help it much because we don't want it to spin like that. If we let go, we want it to stop quite quickly. So I have also next thought I will reuse these, chop them up a bit, so there's 2 layers of that, and then possibly glue some material to the top just to provide some damping. So I think that's next on the agenda, is to do that. I'll clean all the glue and gunge off these and chop them in half, and I guess they'll be going back down with double-sided tape if I'm doing it. Okay, so here we are. So I had 4 of these curved section segments of plastic, so I've cut up 3 of them, and there's 3 stacked up and glued together with double-sided tape and glued down with double-sided tape, and they happen to be, let's see if I can show you this, exactly the same height as the flange here, by fortunate coincidence. So if we now put this in and hold this, there you see it, whiz it round, it stops. That is, well, near enough right that we're going to try it. And then the problem I have is my finger skids on the smooth top of the plastic, so I might get something, I don't know, see if I can get any very thin, like rubberized sheet or something I can put on, or I could put whatever I've done with it, lost it, another one of those little, the feet actually, clear silicone little knobs just to grip onto, or a few of them scattered round. We'll see. So now we need to look underneath, because it's fine as it is, but and underneath goes the magnet, and if it lifts up the magnet will just come off the bottom of the shaft. We've got to cut the shaft off. So I put this, which is just a collar, which is held on with a couple of Allen screws. Like that, and then it's all held in place, and the magnet goes on the bottom. And before I take this off again, I'm going to mark it with a marker pen so I can cut the shaft off. Right, that's marked that shaft, so I can cut that off. And the magnet will actually, so I'm going to cut the shaft so it doesn't protrude out of the bottom of there. So the magnet will actually just stick on there by magnetism. I might glue it on, I might just put a layer of tape, sticky, double-sided sticky on, just to stop it shuffling about. Not that it will, but I don't know. I haven't decided yet. Anyway, I'm now going to go downstairs and cut this shaft off. Okay, here we are, our chopped off spindle. So that end goes down there and we tighten it up. Oh, that's staying. There we go. And take this magnet off, stick this on here. Yes. And Minnie will go crazy. Possibly the postman. There we go. And we're done. I like it. I like it. Except we have a problem. Right, this I've drilled 4 holes in to screw it down to there. Whoops. But how on earth are we going to get screws through this? And if we take these out, how are we going to get the nuts back on? So I shall have to ponder that and come back to you. Okay, so there's probably a clever way I can do it, but what I am going to do is simply drill 4 holes there and there, somewhat bigger than a, well, I don't know, anyway big enough to get a screwdriver through, so I can simply screw through the top plate when it's lined up right. So we need to get these screws in the right place. So I don't fancy the chances of trying to get the camera to see this. It's going to take my word for it, but peeling down the hole there and lining it up with the middle of the top of the rotation sensing chip. In fact, what I might do is put a dot in, a white dot in the middle of that chip. Okay, here goes. Yeah, that's working. Well, a white splodge approximately in the middle. Can't find a chip now, isn't there? Oh, there we go, that's nice. So that's it. So we hold it down. We find the screws don't go through the holes easily. Okay. Okay, forgot to press go on the camera. However, got 2 screws in and it's a little off centre, it's a little that way, about 1/2 millimetre. But we're going to go for it. Well, we shall see. It'll work if it or it won't, right? So I guess the next thing I need to do is mark and drill the holes I want to put in here. Right, so you see that I've just marked the turntable on the base because these aren't perfectly square, so it'll have to line up a certain way. Right, so you're going to get a good view of my head now. Right, there we go. So I am going to drill some holes there, that size-ish, and hopefully that will work. Right, so let's try this. Oh yes, there we go, get out. Okay, there we go. So now we need to lower this down because I've lost it. Lost the magnet again. It goes, gets stuck on the nearest metallic thing and vanishes. Right, hang on. Okay, decided I am going to double-sided tape down the magnet. Shouldn't need it, but gonna do it. There we go. And oops. Well, does this tape not want to stick to this collar? Come on, get down. There we go. Now got to get this on in the middle, hopefully. Right, excuse my head. Well, that's not in the middle. Alright, well that's what we're doing. Oh, this tape's been complete waste of time. However, that's where it's going. Okay, so this face is level with this face, and we've got the height of the collar and the thickness of the magnet and a millimetre before the top of the chip, or half a millimetre to a millimetre. This has got to go down. So let us see if we can drop this. I think we're going to have to put longer screws through and put a nut on the bottom and a nut on the top. What I want to avoid is having to move these wires, because it'd be a pain in the what's it. So we're going to mount it as low as we can without giving those wires room to come out underneath. Okay. And that, unfortunately, I think is the longest screw I have. Okay, few measurements, few sums. I reckon bottom of that magnet is, scribbles here, 11 millimeters below the surface there, which is the surface there, and with a bit of fiddling with the wires we can get that down. Can you see that? No. So it's sitting only one of those knots above the bottom surface, which is 2.5 millimeters, and this from the bottom surface of the board to the top of the chip is 3.5 millimeters. So the total distance, assuming the magnet is flat down against on the chip, is 2.5 plus 3.5 plus 11, which is 18 millimeters. 17 millimeters. 17 millimeters, and I reckon this depth of this round piece here is 16.5 millimeters. So, oh dear. So, what to do? I guess I'm going to get some washers, put them under these screws and space the whole of this assembly up maybe a millimeter, and again mount this as low as I possibly can, which is problems in itself because these, and you can see that there's just enough poking out to get a nut on, and these are the longest 3mm screws I have. So what I'm probably going to have to do is drill into here so I can mount these heads further in by about 5mm. Ah, fun, fun, fun. So I shall set off doing that, and we also have another fun little problem. Having drilled these 4 holes to do the screws up, they catch on the corners of these, I suppose you call them dampers, friction dampers. So I think the best thing to do is just to saw the ends off the top ones, because we can sacrifice a little damping. So I've got to do that as well, so I will do a bit of drilling and hacking and what have you in, and we'll reconvene. Okay, it's a new day and I've decided to bite the bullet and transfer these wires to the top side of the board so I can sit the sensor circuit board flat down here and not have to try and squash all these wires down and potentially break them. So, time to break out the soldering iron and get on with that. Okay, it's all fired up and the serial connected, so let's fire the software up. Okay, that's really what we wanted. Well, any kind of chance of finding this magnet. Let's see if I think that's working. I believe that's working if we look at the first number there. we're going to call that working. Okay, I'm going to drill with a working battery and a drill that isn't blunt as anything. That's more like it. Right, if we now shove 4 screws through there, we should have enough sticking up at the top base here to screw our board down. Okay, reassembled this. So let's put it back on here. Now in a minute we're gonna test. There we go. Clearance between the bottom of the magnet and the top of the chip. But first I realised that those holes line up with the holes in the dowel ring. When that lines up with that, fine, but I did not mark where this goes. So looking back at the footage from previously in the video, I believe it goes that way. So we'll actually throw a couple of screws in. And mark where it goes. I'm trying to think. Okay, here we go. Lots of nice marker pen marks. Looks ever more prototypey. So, maybe we can get this one to work. Yep. What a mess. That's what I wanted to do. Right. Let us get some fun coloured Play-Doh. If we can squish between the magnet and the top of the chip and see how thick, how big our gap is. Okay, here I have, which I found, fluorescent pink Play-Doh. Don't tell the grandsons I've nicked their Play-Doh. So I'm going to put a blob on the chip, and I am going to carefully lower this into position just by eye. So you might get the top of my head here. And that should tell us what the gap is between the magnets and the chip. So I am going to peel this carefully off here. So that's it. How do I measure the thickness of that? That's the next question. You think we can cut it in half? We can always do the whole procedure again. Oh, that seems to have worked. And I would call that, hang on, let's try. I would call that around 1mm by eyeballing it, which I think is okay. So I think we are gonna put this back together and fire it up and see if it's working. Okay, sorry about pointing the camera at the screen, but this program does not like running with Camtasia screen recorder. So we go around here, she's all back together, and there we go. Feels nice. I like it, and I've stuck some of these little rubber thingies on just so fingers don't slip on the acrylic. And if I point this back at the screen, you can see that spinning round nicely. And turn the turntable. Okay, I won't trouble you with all of it because you've heard it, and I am out of practice with this thing. So that is it for this video. We have, well, I'm leaning on the string. We have our turntable Mark III, which I think we are going to go with for now. I like it. It feels nice. So that is it for this video. Nice to do something physical rather than software for a change. Oh, and I did cut these friction, what you call damping whatevers, so the holes didn't rattle over them. So that's it for this video. We will see you on the next ones, and for now it is goodbye from Triplicate.
Goodbye.